Okay, guys, so we've been talking about the idea of factoring out different types of quadratics, and what I want to do is just, in these small little minutes, talk about factoring out special factoring patterns. The first one that we want to talk about is the difference of two squares, or we call it the sum and difference pattern. And an example of that would be a squared minus b squared. And what we notice when we factor that out is it's going to have the form of a plus b. A minus b. And an example of that would be x squared minus 9, which would turn out to be x plus 3x minus 3. If you guys just remember from factoring out quantities, if I look at this format right here, depending on how you guys do it, no matter what, you're going to put r squared and minus 1 there. And I'm thinking about to myself, what gets me 1, or r squared, and that would have to be r and r. And when I'm adding these two together, I'm trying to get a sum of 0. So if I were just to think about it, what gets me negative 1? Negative 1 and positive 1. So if I were to multiply, I would get 1r and I get 1 minus r. So the factoring pattern would turn out to be r plus 1, r minus 1. Okay? If I look at this quantity right here, depending on how you guys do it, I have 4x squared minus 1. I can think about what gets me 4x squared. If I look at 4x squared minus 1, I have a 4x squared, I have a minus 1, and I can think about this as being 4 times negative 1. If you guys do the product sum, I get a product of negative 4, and in this case, I'm trying to get a sum of a 0. What gets me negative 4, but a sum of 0 is negative 2, and positive 2, that gets me a sum of 0. So I could put a negative 2x, and I could put a positive 2x there. If I add those two, I get 0. Factoring out the greatest common factor, I would get 2x, because 4x squared and 2x, the greatest common factor is 2x. Same right there. Greatest common factor between 2x and minus 1 is plus 1. Greatest common factor between negative 2x minus 1 would be a minus 1. So my factoring pattern would be 2x plus 1 and 2x minus 1. But just an easy thing to think about, guys, is if I just look at the square root of 4x squared, what does that turn out to be? 2x. What's the square root of 1? 1. So I could see that I have 2x, 2x, minus 1, minus, plus 1 gets me that pattern that I'm looking for. I'm looking at another example of 27r squared minus 75. I can look at this and say, hey, none of those are perfect squares. What goes into 27r squared and what goes into 75? What is the greatest common thing that goes into those? And I think that's 3. 3 goes into all of those. So I can factor out a 3. Now I'm left with 9r squared minus 25. And if I make my box, I have 9r squared and I have a minus 25 now. And if I just think about, hey, what's the square root of 9r squared? Well, that would be 3r. So I have 3r, 3r. What's the square root of 25? 5. So I can have a 5 there, 5 there. I get 15r and 15r. If I make one of them minus and add those two together, I get the 0 that I'm looking for. So your factoring pattern would turn out to be 3, because that's the largest thing I took out first. 3r plus 5, 3r minus 5. And looking at this example right here, once again, I think that's a 3 that goes into all these terms. So I have 3, and then I have 16 v squared minus 25. So I have 16v squared minus 25. If I just take the square root of those two terms, I think that's 4v and 5. So if I do 4v plus 5 minus 5, that should work out. So I got 20v minus 20v. Add those two together, it works out. So you end up with 3, and then 4v plus 5, 4v minus 5 to be the fully factored out form. I'm going to ask you guys to try the next few questions, and then we're going to talk about another type of situation.